Good day everyone, my name is Aaron Santiago and I'm a third year Bachelor of Secondary Education major in Mathematics, and I'm here to present my math investigatory project, which is entitled Mnemonics for Differentiation of Trigonometric Functions in Calculus. In this presentation, we will be highlighting one of the subjects in mathematics, which is the calculus. Under the topic, we will be highlighting the differentiation as well as the mnemonics, which is highlighted in this math investigatory project. Alongside with the discussion, we'll be discussing the methodology, the conjectures, the results and discussion, the verification of conjectures, as well as the conclusions and recommendations. Mathematics is one of the subjects that is taken very seriously in the school system. The Department of Education, or the DepEd, did many revisions and innovations to improve learners' performance in mathematics. But it is still one of the most difficult subjects in education. Moreover, calculus is a difficult subject among mathematics. According to Shures of 2014, calculus is one of the high failure rate courses for engineering students beside physics and statistics. So there are factors that contribute to difficulties in calculus. First one is lack of understanding of the basic concept. So in mathematics, in the different branch, such as calculus for example, you need to know the basic one. You need to, because this will be your foundation, this is the root for you to bridge, for you to further your knowledge regarding the complex topics. Another factor is the deterioration of mathematics performance at secondary schools, meaning to say there is a decline, there's a neglection of furthering your knowledge in calculus. Meaning to say there is a fall from a higher quality of learning calculus to a lower one. Meaning to say they do not prioritize this subject anymore. So another factor is the mismatch of teaching and learning culture between secondary schools and university. So given that some schools really made this subject, put this subject in their curriculum, that's why they improve, they excel in this subject, while other schools doesn't really pay attention on this subject. That's why some students, these subjects really make it difficult. So many of us really found mathematics as a difficult one, a difficult subject, because there are a lot of formulas to be memorized, there are a lot of problems to be solved, and the way the teachers teach is very a traditional way. That's why students really do not have interest on learning this subject. So as traditional methods of teaching, mathematics have been found to be ineffective due to lack of performance in certain topics of mathematics. An innovative change needs to be implemented. So according to Purbaningrum et al. Of 2023, the lecturer or the teacher itself must explore and be creative in teaching instead of simply giving them the solutions to mathematical problems. Lecturers could train their students to actively work for alternative solutions which help them to think creatively. So due to the lack of performance in calculus, this study will focus on improving the way that students memorize formulas of basic differentiation. So there has been many research studies that find on the importance of diagrams in the solutions of mathematical problems, according to Dricast et al. Of 2022. So we will be discussing the diagram, the visual mnemonics, on how does it affect the learning calculus. So diagrams has been identified as one of the most effective strategies that have been proposed to improve efficiency in mathematical problem solving. So generating diagrams to solve mathematics problems can help learners in numerous ways. So this research is according to Toulis and Key of 2022. So accordingly, visual mnemonics play a pivotal role in facilitating conceptual learning by providing memory aids and organizing information in a memorable way. So this is according to Al-Makbali et al. 2022, Chirati et al. Of 2023, and Nakamura of 2022. Moreover, according to Toulis and Key of 2022, mnemonics provide learners with memory prompts and mental cues that help them recall complex concepts more easily. Mnemonics play a crucial role in aiding memory retrieval by providing learners with effective strategies to recall information. So it is presented here that using mnemonics, using diagrams can really improve our learning because we can easily recall facts, we can really easily retrieve information, which it led for us to have an effective strategy in learning. Because it's personally I use mnemonics for me, like for example when during quiz, during exams, it can really it can really help for me to answer the given questions, given that there are a lot of concepts that need to be memorized. So when it comes to the methodology, so this paper is an expository study about formulating efficient ways on finding the derivatives of trigonometric functions. So rather than confirming hypotheses or testing theories, this study primarily focuses on discovering new insights, proposes new flexible methodologies, and offers thorough explanations and detailed solutions that the reader can understand. So given that finding solutions about the trigonometric functions, finding its derivatives is already hard, so in this paper I will be explaining how to get these derivatives using the mnemonics that is being proposed. So now let's move on with the results and discussion. So this section provides a review of trigonometric functions and their derivatives. We recall the definition of the derivative as a function of x defined for all the real numbers x. Subsequently, the verification of results of applying the mnemonic charts to derive trigonometric functions are presented. So this charts, I've already have here the derivatives of trigonometric functions. So let's evaluate it one by one. So the derivative of sine x is equal to cosine x. The derivative of cosine x is equal to negative sine x. And the derivative of tan x is equal to secant squared x. The derivative of cosecant x is equal to negative cosecant cotangent x. And the derivative of secant x is equal to secant tangent x. And last, the derivative of cotangent x is equal to negative cosecant squared x. So we have here the mnemonic process for differentiation of trigonometric functions. I made this personally. So on the upper part we have the positive, and the lower bottom we have negative, on left we have negative, and on the right we have the positive sign. In regards naman with the trigonometric functions, the sign is placed on the upper part and on the lower part, and the cosine is placed on the left and on the right. And the trigonometric functions within the triangles are secant, and tangent. On the bottom part, we have cosecant, cotangent x, and we have the cosecant x. So this is the steps for the mnemonic process of differentiation of the trigonometric functions. So this tackles on how my illustrations were put together. So step 1, so we draw triangles, one in standard orientation and the other in a reverse orientation, just like what I have presented earlier. So step 2, the trigonometric functions were classified into two groups based on the sign of their derivatives. So the functions with positive derivatives were associated with the top and the bottom. All the functions are on the top of the bottom, while the negative derivatives were associated with the left and the right. Let's proceed with step 3 and step 4. So step 3, the differentiation formulas for the trigonometric functions positioned outside the triangle can be obtained by following clockwise direction. So we're just going to follow how the clock works, that in that direction. That's how it works. So step 4 Therefore, the differentiation formulas for the trigonometric functions within the triangle can be obtained by multiplying the adjacent function or the neighboring functions inside the triangle. So there's a note here that for the trigonometric functions within the triangle, the positive or negative sign is associated with the derivative solely determines the direction of the function's change. The signs are independent of any specific trigonometric functions since it is only indicative signs of the corresponding solutions to the derivative of the trigonometric functions. So meaning to say that the signs that is associated with the trigonometric functions does not solely mean that it is the answer. It is only indicative of the function's change. So while the trigonometric functions outside the triangle, the signs are dependent and it indicates the corresponding solutions to each derivatives. So next is the verification of conjectures. We're going to verify if the conjectures that we have earlier, the derivative of the trigonometric functions can really be applied in the mnemonics chart. So this section presents a verification of the proposed conjectures. Solutions are provided demonstrating how the mnemonic chart can be applied to derive trigonometric derivatives. So the instructions earlier, the steps that I presented may not be clear to you. So in this process, in this verification, we're going to clarify everything. We're going to go through step by step for you to understand how this mnemonic chart really works. We have here the verification of conjectures. First one is the derivative of sine x, which is the cosine x. So from the steps that we have earlier, we need to move clockwise direction. So we can get that the derivative of sine x is positive cosine x. So since the positive or negative signs are dependent to the trigonometric functions, meaning to say the answer will depend on the signs that in where they were placed. Like for example, the positive sine x, the derivative is positive cosine x, and the positive cosine x, the derivative is negative sine x, and the derivative of negative sine x is negative cosine x, and the derivative of negative cosine x is positive sine x. You just need to move clockwise. So let's move on with another derivative. The derivative of cosine x is equal to negative sine x. This is the same just like the explanation that I have on the first derivative, since the sine x and the cosine x are placed outside. So we have here, by moving clockwise, again we can get the derivative of cosine x, which is the negative sine x. Let's move on with the third one. The derivative of tangent x is equal to secant squared x. So from the explanation that we have earlier, since the tangent, the secant, the cosecant, cotangent are placed within the triangle or inside the triangle, meaning to say they are independent on the signs. They are just simply indication of the functions change or the answer. Like for example, in this tangent x, the derivative of tangent x, as tangent x is located within the triangle, its derivative can be obtained by multiplying it within the adjacent functions or within the neighboring functions. Like for example, tangent, the adjacent functions that we have in the upper triangle is the secant x and the negative secant x. So we're going to multiply those two functions. So based from the chart, there are two signs given. One is positive and the other is negative. By multiplying these two, we can get negative. Therefore, the resulting product with a negative sign yields the derivative of tangent x as positive secant squared. So for the next verification, the derivative of cotangent x is equal to negative cosecant squared x. So these trigonometric functions are found on the bottom part of the triangle. So as cotangent x is located within the triangle, its derivative can be obtained again by multiplying it with the two adjacent functions, namely 2 positive cosecant x. So based from the chart, there are two negative signs, and by multiplying these two, it results to positive. Negative times negative is equal to positive. Therefore, the resulting product with a positive sign yields the derivative of cotangent x as positive cosecant squared x. In this case, it does not result to negative cosecant squared x, since the derivative of cotangent x is negative cosecant x squared. Therefore, this study has limitations in which finding the derivative of cotangent x is not applicable in this mnemonic chart. So for the fifth verification, we have the derivative of secant x is equal to secant tangent x. So again, they are fine. They are located within the triangle. So its derivative can be obtained by multiplying the two adjacent triangle within the triangle. So they are namely negative secant x and positive tangent x. So based from the chart, there are two signs given. First one is on the left side, which is the negative, and on the right side we have positive. So by multiplying those two, we will get negative. So therefore, the resulting product with a negative sign yields the derivative of secant x as positive secant tangent x. So last one is the derivative of cosecant x is equal to negative cosecant cotangent x. So again, since they are located within the triangle, they can be obtained again by multiplying the two adjacent functions, namely positive cotangent x and positive cosecant x. So based from the chart, there are two signs given again, the negative and the positive sign. So if we multiply those two, we can get it will result into negative. So therefore, the resulting product with a negative sign, it yields the derivative of cosecant x as negative cosecant cotangent x. So for conclusions and recommendations, mnemonic device involves reorganizing information and advantages for students to become more active learners. Mnemonics have the potential to benefit learners across all educational levels. If students master the practice on how it works correctly, they can solve the given problem successfully. These strategies can transform passive learners into active and effective learners. By mastering these techniques, students of all abilities can improve their problem-solving skills. So indeed, these mnemonic devices really can help us to retrieve and recall information that will really help us to become an active learner. This is an advantage, or this is an edge for us to ace our exams, to ace our quizzes, because we don't need to memorize the formulas, we don't need to know the step-by-step process. Instead, we're just going to go back to the mnemonic device, the mnemonic chart that we have. Since especially this is a math subject, it's really hard for us to many students really find the subject a difficult one. So this can really help this is really an effective strategy for us to employ during the math class, especially for teachers to become the class more engaging, more active. And also this will also help teachers not just from the secondary level, also from the university, from tertiary level, of all levels regardless of their abilities. So one of the goals of this study is to provide alternative technique which is more interactive for learning and teaching strategy. And directly, this would increase students' comprehension and improve test performance. So This can really, by really just recalling this mnemonic chart, you can really improve your test performance. Not just, and it will also not benefit just the learners but also the teachers. They can easily they can easily discuss the topics by using these mnemonic devices. And on the recommendation, the researchers advise us to conduct if integration of trigonometric functions can be applied using the same mnemonics. So, since in this math investigatory project, this only highlights the differentiation of trigonometric functions. So, I am truly yours is advising if you can this for the future researchers, if they can use this same process, this same mnemonic chart on the integration of trigonometric functions, same subject in the calculus subjects. Since after the differentiation topic, you're going to move forward on the integration part. So additionally, the research recommends the usage of these mnemonics as an alternative approach in teaching and understanding the concepts of trigonometric functions in calculus. So for teachers, for learners, it's a good way to use this, as you can improvise this or use this as an alternative approach, so that you're it's an easier way to deliver the lessons in calculus. So this paper can also be studied by future scholars who can also propose simpler mnemonic methods. So given that some of you may not really understood it well, may not understood it clearly, so future scholars, I'm advising future scholars to propose simpler mnemonic methods for, so that learners can really understand it in a simpler way. So that will be all. That's my math investigatory project, the mnemonics for the differentiation of trigonometric functions. So that will be all. Thank you.